Swayam Prabha. Digital India. Educated India.
Okay, what we will do is look at few examples and try to answer them. Okay. So example 1, okay, it's asked, what it says, the several studies have shown that the power plant, that 95% of the sulfur is in the coal is emitted through sulfur dioxide. Okay. And then you have to, what you have to do, derive an expression for emission factors. We all know about the importance of the emission factors, so we need to have good emission factor to estimate emission inventory. Okay. With this emission factor you can find out what will be the emissions, let's say in Kanpur area, you can find out the total emissions in the Uttar Pradesh state, you can find it in India, and you can do the comparison from state to state, intercomparison from one country to another. So emission factors are very, very important. So what you see, the 95%, see simply see the sulfur dioxide, it is the sulfur which is present, and if you recall we said the sulfur in the coal, almost entire amount of the sulfur is converted to sulfur dioxide, if you recall the earlier discussions. So that forms SO2. So here you see, simply think 32, if I take the molecular weight and this is 32 and this gives you 64. So whatever is the sulfur, you get the sulfur dioxide twice of that one. Okay. So the sulfur content, let's say in percentage, okay, is S, or the real sulfur is times, this is sulfur percentage. Okay. So this is sulfur the percent, or this is the sulfur fraction in the coal. So if you take this as 2 times of this one will be sulfur dioxide that will be emitted. Okay. And the 95% of this one comes out, not entire thing is converted as per our definition or as per the problem. Okay, this is 0.95. Okay. So this is what, this is the emission in what units, depend on what is the coal units you have taken. So this is what is, let's say we are talking about 1 ton of coal. So this is the tons of sulfur dioxide. Okay. Can someone quickly convert this into the kg of sulfur dioxide? Okay. Kg of sulfur dioxide per ton of coal, as we require kg of SO2 of per ton of coal for coal having percent content of sulfur. Okay. And then I want to, what I want is in kg of SO2 how much is the thing which is coming out? Quickly write that thing to me. This is the sulfur content S, which can vary from coal to coal, which can vary from oil to oil and things like that. How much that coming? I have not done the calculation, although I know the number, but if you can quickly tell me what is that coming out to be. See, S is a variable, right? In the coal, sulfur content will vary. You take a coal from Assam, it will vary. You take coal from the North Field, it will vary. You take this coal from lignite in south, that will vary. So what that factor comes out to be? What is that coming out to quickly? Can you do that? 19s, correct? Okay. So that is what is the factor I wanted you to do, is come up with a 19s. That much of kgs of SO2 will be emitted by burning 1 ton of coal, right? Is that clear to everyone? Suppose the same example I had, and I said suppose the coal has the ash content of A%, okay, and I also gave you the example that 85% of ash is emitted as fly ash. Okay, find emission factor, and generally, okay, it is not a standard thing. We write the emission factors in kg of whatever the pollutant which we are talking about per ton of fuel or coal, okay, and then why I am writing 85%, those you might slightly remember if you call, when you burn the coal there are two types of ash which comes out. One is a fly ash that goes up through the chimney, and there is something called bottom ash which falls at the bottom of the boiler, and generally the bottom ash is about 15%. Okay. So same way, the way we develop the factor, so this will, I am not doing the calculation, this will come out something like A is in percentage of ash, kg of ash will come out as a particulate matter. So I can write kg of PM, that is particulate matter per ton of coal, and you can check. So that is how the emission factors are developed or derived. Okay. I just extended the example from sulfur to particulate matter emission that may come out by the burning of the coal. Okay. Well, somebody can ask as to why 95%. They are based on lots of experimental studies which have been done, and they found out that, well, theoretically all sulfur should burn to sulfur dioxide, but in fact it does, but some in the process, the combustion process is converted to SO3, and part of the sulfur dioxide is absorbed by the fly ash, very little amount, and that goes and that somehow gets removed. So that was just an idea how the emission factors are calculated. Let's have a question 2. Okay. It says an oil refinery, and what is the important thing in the bracket is an isolated source, has been accused of contributing serious air pollution to the ambient air in the surrounding area. The following information is available. Okay. Okay. Wind direction, only 4 directions are available: north, east, south, west, and wind speed in kilometers per hour is in this range. And when wind is from north, okay, we always remember when wind direction is north, it means wind is to north or from north? From north. Okay. So we say when wind is blowing from the north, 70% of time the wind speed range is this one, 20% time is this one, 10% of time is this one, and the frequency of wind blowing from north is 50%, and the mixing height that is defined, and that you know very well now, is the mixing height, vertical distance up to which the pollutants can disperse. Evolve an impact factor for each direction based on linear sum, okay, of the inverse of the mixing height. So I'll write in factor for direction n, okay. So the impact factor for direction north, I can write this as whatever it says, we'll do this one, inverse of the mixing height, and whatever units are given you don't have to change, okay, inverse of mixing height. So 1 by 300, linear combination of what? The second thing is percent, okay, frequency of the wind direction. So that is percent frequency is 50 plus third thing is what? Inverse of the mean wind speed. So mean wind speed, so we have to calculate the mean wind speed for the, we are talking about north. So what you can do is 0.7 times 2 plus 1 3 plus 0.2 times, that is you are finding out the mean wind speed in the direction north. What do I do? 0.2 times, what do I write here? 8, okay, plus, that is 10%, so 0.10 times the average wind speed in this range will be what? 12.5. See, the range is 10 and 15, so average is 12.5. I don't know if you can see that, and this is, I have to write everything in inverse because it says this is inverse. So plus 1 by this. Okay. Then what it tells you, with the obtained impact factor, okay, with weights factor 0.15, 0.65 and 0.2 for 3 terms, 1 term, 2 term, third term. So this is impact, the weightage for this one is how much? 15. This is at 0.65 and this one is how much? 0.2. So this is impact factor for north. Okay, I thought the problem is very clear and straightforward. Okay, so that is what you have to do. So that way you can find out the impact factor for various direction. Okay, and very quickly you can see, at least for this example, this is going to be a very small number. Okay, this is going to be a very small number. Okay, the fraction of something 0.7 into 3 and this and that comes out to be 4.5. Okay, so major number, the large number will be this. Okay, you can do the entire calculation, or simply you can assume that these two big, you can ignore them for simplicity. Actually you should find out the full, but if you really will see how much this will come out to be, close to 32.5. So this one you can say. So largely impact factor is depending on the wind direction. So it will be 32.5. What will be here? Anyone can give me the number? 20 into 0.65. So that is about 13. Okay, right? 13. And then you have 10 here. So 10 into 6.5. Okay, that is about 6.5. And this one will be again 13. So what you can write, the maximum impact factor is from north and minimum is, minimum impact factor is of that south. Okay. If you recall, I said in the class, when you want to find out the impact of a source, what you do is you try to look at the downwind direction where the wind is blowing most of the time, and the direction in which wind never blows. So that will have never impact of this thing. So you say the factor, to see the impact of this one, where should I put my station? Because question asks you that what should be the two locations. Okay, what with the obtained impact factor, okay, find the directions of two sampling locations which would assist in reaching a just conclusion if industry is really contributing to the air pollution in the area. So you see here, so if I have to see them, I have to see the maximum impact, I must go and put my station where? North or south? South, because when wind is blowing from the north, the impact is maximum, right? So I have to put one station here, that is my station 1. Okay. And where do I put the another station? In the south, because that's where the impact will be minimum. When the wind blows from south, okay, the impact will be minimum. So when wind blows from south, it means the impact will be north. So I can put second station in the north direction. And then I have to really see the difference of the levels what one obtains at ST1 . If this difference is too much, then the industry is causing problem, otherwise it is not causing. Okay, some of you have got this one right. Okay. Is this clear?
So what if we take the basic percentage, because we are ultimately comparing for the all directions. So it won't matter if we take exact value of 50 or 45 frequency for all times.
Here, what do you say? If we take it 25,
0.5.
it will not matter. It will not matter. But see, the thing is, the way question is asked, okay, you can apply your mind, but the way the way the question is asking to formulate a problem, you formulate the problem the way it is asked. Okay, you may disagree with the problem. You may say, well, wind direction is not important. You think the mixing height is important. But well, that is your understanding and logic. But when we are trying to do a problem, we try to do exact what problem wants us to do. Okay, this is not. It's just some idea to give you that how air pollution could be related with mixing height. The things how to find really the impact in terms of the quantification. The things are more complicated, but this was just to establish what is the direction where we do this sampling to establish if industry is really causing a problem or not causing a problem. Okay. And in this figure, remember that your what is that? Oil refinery. Oil refinery, we are assuming the oil refinery is sitting here, right? Okay.
Why we are not converting the mixing height here in kilometers?
See, you can convert that too, but unless you have been asked to do that, I mean, you take the number the way it is given to you. Okay, this the factor is really dimensionally not correct. It's just arbitrarily a factor has been decided. Okay, even if you take that in kilometers and things like that, your answer will not change because purposefully lot of weightage is given to 0.65 to the wind direction. And that's what was the idea that you. Okay, let's try to do the next problem. Okay, this one was, of course, it required some formulation, some thinking, but then it was not so difficult either. Okay, this is the aluminum refinery, all of you know that. This is your reduction pot. This is what we call as the primary emissions. If you recall, whatever cannot go through the hood, which is like this is kind of hood, if you recall. So these are the emissions which are going through the hood, but some emissions, as you will see, will escape, and that is what we call as the secondary emission. And then this is go for the primary control, and these emissions which are secondary goes for the secondary control that we had discussed earlier. Okay. Now the problem says, okay, fine, so much of tons per year. aluminum plant are 20 kg of fluoride. Ft here is the total fluoride. That means Ft represents particulate as well as a gaseous fluoride. Okay, particulate and gaseous for every ton of the aluminum produced. The industry wishes to install both primary and secondary treatment, as you see there. Control system, so to attain an emission standard of 1 kg of Ft per ton of aluminum produced. The following details are there. Gaseous component is 40% of the total fluoride. Removal efficiency of the secondary control system, okay, for gaseous and particulate both is 60%. Removal efficiency for primary control system for gaseous and particulate is 98%. The collection efficiency for gaseous and particulate fluoride at hoods varies. Okay. If the collection efficiency of the gaseous fluoride is 90%, okay, what should be the minimum design efficiency for particulate fluoride so that the industry meets the emission norms? Okay. If you understood the problem, what it is saying, the collection at the hood, okay, it varies. It varies for gaseous and it varies for the particulate. Is that clear? Okay. Maybe when we did earlier, we showed that the collection efficiency was the same. Okay. So now, so let's talk about the uncontrolled emission first. Okay. Which emissions? Primary emissions. Okay. So what I can say, collection efficiency, and then I can, in this one I can have the two components. I am talking controlled primary emission, let us say particulate side, and let us say I write the gaseous side. Okay. So it depends on the collection efficiency of the gaseous. So I can write this as Cg, okay, and here I can write the particulate. Okay. How much is the particulate emission? 20 is the total. Okay. Out of that, how much is the particulate? 20 is the total Ft, the 20 kg of total fluoride, and you say the gaseous is 40%. So how much is the particulate there out of 20? Are you sure? 12 kg. 40 is gaseous and so particulate is 12 kg. So you can say this one is, and we all, as I told you over and over again, in aluminum industry, we always do all calculations based on kg per ton of fluoride. Even if you want to talk about the gases required, you say kg per ton of fluoride required. Okay. So if you say that, if you agree, then I can write that as 12. Okay. What do I write here? 8. Okay. This is the uncontrolled particulate primary emissions. Okay. If I also want you to write uncontrolled, let's write a little below here, uncontrolled secondary emissions. Okay. If you like, again we can do separately for particulate and this thing. So here what I do write 1 minus NCP, right? This has gone into the primary. Okay. So whatever is remaining, okay, that is 1 minus NCP will go through my secondary emissions, uncontrolled. We are not talking how much is the controlled. So I can write this one 1 minus NCP times 12. Here I can write 1 minus NCG or eta Cg times 8. So far no problem. If you have a doubt, you ask me. Now I want to do, what I am really interested in is the after the control device. So once I am controlling this, okay, let's see then after control how much will be left over. Control efficiency or removal efficiency of the primary control system is 98%. Okay. So how much is the emissions from the particulate? If you agree, I will write the numbers. 0.02 times NCP Agreed? Because 98% is removed. What I am, and then don't forget that what I am trying to do here is emissions after control. Okay. So this is the particulate, because 98% removed, left is 0.02. Okay. And here again 98% is removed, the left is into 8. Agreed? Similarly, what do I write here? Out of this, how much is controlled in secondary? How much percent is controlled in secondary? 60%. So I can write here for the gaseous side. So now what I am trying to do underneath this one is controlled emission, controlled secondary emissions. Okay. So I say if 60% is removed, how much would go out? 40%. So I say 0.4 times 8, and here also it is same. So 0.4 I leave you to see this one now. Again 60% is removed, so 40% we are talking about controlled secondary emissions. So much are emissions still going to atmosphere, particulate and gaseous. In primary, particulate and gaseous. Okay. Let's see. Do you know NCG or eta Cg given to you? How much is the number? 90%. So here you can write 0.9. Okay. This one also is 0.9. Okay. This also is 0.9. Okay. And then I'll to find out the total emission. What is my total emission? Through the primary source, particulate plus gaseous. Okay. Same thing I'll do here. Okay. Particulate plus gaseous. Okay. And now suppose if I am calling this as A and this as B, with the definition or with the problem, A plus B should be equal to or less than 1, right? That's allowable emission. Where do we see that from? So that industry meets the emission norm. And what is the emission norm? The industry wishes to install both system to attain an emission standard of 1 kg. So this is equals to 1. I am not writing units on purpose. So if you have so only a known that is there is NCP or eta Cp, and that answer that comes out to be, we are not running through the calculation part, that came out to be and many of you have done correct. Is that part okay? All right? Clear? Okay, very good. So the problem was simple, but it needed to be formulated properly. And we expect you to, given a situation, you must be able to formulate the problem. No one will ask you straightforward questions that this is a formula, put in the numbers, right? You have to spend some time understanding the problem. In fact, formulating a problem is sometimes more difficult and more important than getting the solution. Because solution you will know once you write the problem properly is sometimes just simple, it could simply be algebra, right? But the formulation, and the formulation comes from your understanding of the problem. I want to spend little time talking something which some of you might know rather well and some of you may not know at all. Okay? So for the benefit of everyone, If you recall what we were trying to do in the last class, we were trying to estimate the solar insolation. How much is the amount of radiation that is reaching on the earth? And we said if we know that, we know our stability, right? With the tables that we discussed last time, if you know the incoming solar radiation, but to get to the incoming solar radiation, we have to spend some time understanding few terms, not into the great details, but you see the picture here, the two terms that we are trying to define here, H, okay, and alpha. This you can think of what you see here, north, east, south, west. Take this as the horizon.